Printed circuit board signal conditioning process. The process of data acquisition is known as signal processing. This acquisition is done by an instrument which is known as the signal conditioner. There is a conversion of signals that happened in this process. The signal conditioner converts the signal from one form such as electrical or mechanical to another form. The input signal is converted into the output signal in the signal conditioning process. Now the question may arise, why do we need to convert the input signal into an output signal? The simple answer is that the signal needs to be amplified. This amplification helps the signal to be converted into a compatible and easy to read form. This form of signal helps in data acquisition and machine control. Analog signals are converted into digital signals, but before that, correct preparation is made. In the signal conditioning process, we manipulate a signal in a way that it can be converted and further proceed for the next step. Mechanical and environmental measurements are made in many electronic acquisitions for the measure. These measurements are done with the angle of specific sensors such as temperature and vibrations. But these sensors cannot work accurately for the measurement of the signals if the signal conditioning is not compelled yet. Certain signals tend to have a very low voltage level. For these types of signals, amplification is required before they can be digitized properly. The best example of these signals is thermocouple signals. Some of the other sensors such as accelerometer, strain gauges, and resistance temperature detector cannot work until the excitation to operate is not completed. All these technologies are the best example of signal conditioning. Because of its importance, we can say that signal conditional can be considered as the fundamental block of modern data acquisitions taken in consideration during the PCB design step. Physical measurement is the end goal of the data acquisition system. The following basic components are achieved by the signal conditioning process: analog to digital converter, sensor, signal conditioning computer with DAQ. Use of signal conditioning. As discussed before, the basic task of signal conditioning is the conversion of the signal. The signals are converted from the input form to the output form. Most commonly, the input signals are of the electric type. Now, why the conversion is required? This conversion is needed when the conventional signals cannot process the actual signal easily, and it needs to be converted so that interpretation can be done correctly. Frequency, electric charge, AC voltage, electric current, DC voltage, and current are basic signals that are accepted by the signal conditioning process. A data acquisition system cannot work until it is connected to several signals and a wide variety of sensors. The arranged process is happened for the signal converting. The analog signal is taken by the signal conditioner for better manipulation. Once the signal is manipulated, it is then sent to the analog to digital converter system. The analog to the digital converted system is the end resource, and it helps in digitizing the signal so it can be used in further processing. The basic purpose of the signal conditioning business is the conversion from analog to digital signals. The digital domain is achieved by this process, and this domain is then represented, displayed, stored, and analyzed. Input can be measured from a sensor that is used to measure strain, temperature, resistance, and acceleration. Moreover, the input can also be achieved by relays, switches, encoders, and clocks. A huge number of varieties can be interpreted from signal conditioners. This variety of signals include the output type. There are some basic functionalities of the signal conditioning process. We will see the functionalities later. First, we need to understand the process of signal conditioning after the printed circuit board fabrication is done. Process of signal conditioning. Following are the steps that are included in the signal conditioning process. The detail of every step is given for better understanding. Step 1. Adjustment of a signal according to noise ratio. The signal is adjusted to the noise ratio with the help of amplification and attenuation. In the electronic dictionary, you can say that amplification and attenuation are two opposite subjects. The deterioration of analog signals happens because of the background noise in the transmission process. There comes the term signal-to-noise ratio. This means the signal strength ratio to unwanted background interference. This ratio is then increased with the help of amplification by magnifying the voltage level of the input signal. For example, in amplification, a signal of 0-1 mV is converted into 0-10 V. On the other hand, in the attenuation process, the input amplitude is decreased. This process is done so that the signal can be fit in the optimal range of the device digitizer. Step 2. Removal of voltage signal. For the prevention of equipment from damage, the filtration and isolation of the input signal are required by the signal conditioning process. This is done because the unwanted background noise that is unwanted needs to be removed. Moreover, the removal of voltage signals that are far beyond the inline digitizer is also compulsory. There is a considerable difference in filtering and isolating processes. The filtering is done when noise needs to be rejected from a predefined frequency range. We can say that the isolation process is somehow similar. But the difference is a protection step of data acquisition and control system form. The from voltage spikes is done. These voltage spikes can damage the entire data acquisition system. Step 3, using controlled current or voltage for excitation technique, transducers and their subtypes require the excitation process. The operation of an active sensor is done with the help of the external sensor. A few types of signals that require external power to proceed further are strain gauges, accelerometers, transmitters, resistors, thermistors, and RTDs. Step 4, signal linearization. Sometimes a signal cannot exhibit a linear relationship to the actual measurement. These types of signals can also be produced by some sensor equipment. To overcome this problem, we need a linearization process. As clear from the name, linearization is done to optimize the signal according to the actual measurement. The voltage of the input signal is mapped with the corresponding value requirement by physical measurement. Linearization is a very common signal connection process. The most important use of linearization is in industrial temperature measurement. Now you have understood the process of signal conditioning in depth. Above mentioned steps need to be followed step by step for better signal conversion. Now it is necessary to understand the basic function of signal conditioning. How it is done and what are the benefits of signal conditioning. Let's understand the functionality and the benefits of this process now. Functions of signal conditioners. As we have discussed before, the main functions of signal conditioners are filtering, isolation and amplification. If these steps are not done correctly, then inefficiencies and inaccuracy can happen. These can lead to incorrect output, loss of data, and other problems. So, the question arises how you can avoid these problems. Now, how would you know which type of signal conditioning is best for you? Well, the type of input signal you are going to use for processing will decide this. The other factors that make an impact on the type of signal conditioning process are desired type of output, available power for isolation in the quality criteria of the signal. Now let's understand the basic PC board functions such as accuracy, flexibility, and the isolation required by signal conditioning. Accuracy. Accuracy is the main thing to be noticed in the signal conditioning process. There is a broad variety of accuracy along with signal conditioning. There is a direct relation of accuracy between the conditioner and the accuracy of the other equipment. For example, the sensor that is used to provide the signal. An extremely accurate signal conditioner cannot perform well if the sensor is used in the process is not precise and working correctly. So, in a nutshell, you can say that to get the highly correct and efficient output, every degree of accuracy should be the same in the signal conditioner and other parts of the system. Otherwise, the device and cost would be wasted with a high level of precision. Flexibility. As clear from the name, flexibility in the signal conditioner means processing with a number of signals. A wider range of signal types can be processed with the flexibility feature. It is often considered as an additional advantage. Many designers and manufacturers add this feature to the product just to increase its functionality and efficiency. Because if the device is dealing with a wide range of signals, it is likely to be more precise and calibrated for sensors. The replacement and change of other important parts of the system can be done with the help of flexibility. This will not affect the other part of the system. Isolation. Isolation is used in the signal conditioning process at more than one point. As clear from the name, this process isolates the components and encourages that there is no interconnection between electric and other parts of the devices. The isolation process is required because it will enhance the common quality of the system. Moreover, the signal that needs to be isolated would also be decided according to configuration. Should you have any further questions regarding the signal conditioning process, feel free to contact us at sales@pnconline.com. PNC is providing a turnkey solution to all your SMT assembly and bare board requirements across the United States. Requirements across the United States.